Hey guys, so today we're going to be starting something new in math. I'm not going to tell you what it's called yet though. We're going to get into that as the video goes on, okay? But for now, we're going to use a little bit of our imagination. Okay, so if you guys were here in the classroom, right now it's just an empty classroom, but if you guys were here and I was doing a math lesson, I would need to make sure that I had enough materials for everybody in the class, right? If not everybody has a pencil, I need to make sure I have enough pencils. Same thing with paper and same thing with manipulatives. So manipulatives are like things that we use to help us to see our math that we can put our hands on, like these linking cubes. That's what we're going to be using today. See, linking cubes. If I was doing the lesson with you guys here in the classroom, I would need to make sure I had enough linking cubes for every single student, okay? So if every student in this room needs to grab a handful of these cubes from this bucket, how many cubes would a 5th grade student, would you guys be able to grab? So if your hand went in here, about how many cubes do you think you would be able to grab? Now these are just little cubes, so they're very small. You can see them in my hand like that. And of course your hands are a little bit smaller than mine because you're kids and I'm an adult, right? So we're going to be using our imagination today because obviously I don't have any 5th grade students in here. So we're going to use some people around our building. So we're going to go around, everybody's going to grab a handful. We're going to see how many they get and then we're going to move on with our lesson. So let's go see who we can find. Okay guys, I found Miss Burnett. So Miss Burnett, if you will just reach your hand into this pot of, or this box of linking cubes, and pull out one handful and then just count how many do you have, and you're gonna write it down on these sticky notes and you can use this pen.
They just flew in.
So just count how many you got.
16.
All right, and you just write 16.
I was about to say, was I supposed to say it?
Oh yeah, you can. And then if you'll just write like Miss Burnett real small at the bottom so we remember that it's you. Okay, yay. Thank you, Miss Burnett.
You're welcome.
Okay, guys, now we found Miss Gentry. So she is going to pull out one handful of those linking cubes. Just one handful, Miss Gentry.
Just one handful.
Yep. And then just count how many you got and then write it down on your Post-it with your pen.
All right.
All right, Miss Gentry and her handful got 5 linking cubes. All right, thank you, Miss Gentry.
You're welcome.
Oh, look who I found, guys. Officer Huff and Nurse Watkins. So they're going to reach in our little cubes right here. They're going to grab one handful and then count and see how many they got. Whoop, one handful. So I totally forgot to film a clip of Officer Huff and Nurse Watkins with their count of their linking cubes. So Officer Huff had 39 and Nurse Watkins had 27. Okay guys, now we got Miss Littlejohn. So she's gonna reach in our bucket and grab one handful and then just count and see how many cubes she got.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24.
24. So I'm going to write it down on Miss Littlejohn's piece of paper and let's see who we can find next. All right, guys, I found Miss Cooper. So she is going to pull out one handful of our linking cubes. So one handful. And she's going to count out how many she has and write it down on her paper.
5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37.
37 for Miss Cooper. 37. Okay, thank you, Miss Cooper.
Okay, you're welcome.
All right, guys, I found Coach and Miss Taylor. They're going to reach in and grab one handful, and they're going to count and see how many they get in one handful. All right, so they're going to count these. Okay, so Coach got 35. Miss Taylor got 36. All All right, thank y'all.
See
All
ya.
right, guys, I found Miss Minnick. She's our last person. So she is going to take one handful of our linking cubes. And she is going to, whoa, she is going to count them and write her number on her sticky note, just like everybody else. All right, Miss Minnick got 55 cubes. She's adding it to her sticky notes and her name. Thank you, Miss Minnick.
You're welcome.
So these are all the numbers of the linking cubes that everyone pulled their one handful of linking cubes. So when you're looking at all of these numbers, I want you to take a minute. I want you to try to predict, okay? Just take a minute, think about it, look at all these numbers. If you had to predict what number of linking cubes an adult would pull out of the box, if just any average adult came in and pulled out one handful of linking cubes, how many do you think that they would pull out? So now that you have made your prediction, you looked at all the numbers, you predicted how many linking cubes would the average adult reach in and pull out just one handful, okay? Now that you've made your prediction, let's talk about how we use this data. So anytime we have a set of numbers, just like that set of numbers that I had on the desk, the Post-it notes, that's our set of numbers. That's called a set of data. And mathematicians have developed some ways that they call measures of center to make decisions about what a good number is to represent a set of data. And today we are going to look at all of those ways. So the first thing we need to do is we need to take all of our data. So all of these numbers, this is our data. So the first thing we need to do is we need to put it in order from least to greatest. So the smallest number to the biggest number. So we're going to do Miss Gentry first, and then Miss Burnett, and then we have the 20s, so 24, 27, then we have the 30s, so we have 35, 36, 37, 39, and then Miss Minnick down here had 55. So here is all of our data. So from least all the way to greatest. So now that we have all of our numbers lined up from least to greatest, now we're going to draw a line plot, which a line plot is pretty much the same thing as a number line. So I'm just going to draw my number line just like this. I'm going to start with 0 down here, 0, and I'm going to count by 5. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So now I'm just going to go through and number all of these. Okay, so here's my completed line plot. So I went from 0 all the way to 55. So that way I could fit all of my data that's up here in my sticky notes on my number line. And so the way I'm going to do that, when I make a line plot, I'm going to use X's, okay? So just like this. An X represents one adult. Okay, X equals adult. So I'm just going to go and plug in all of my numbers from my data onto my line plot. So the first one is 5 for Miss Gentry. So I'm just going to put an X over the 5. Then I'm going to do the 16. So I don't have 16, but I have 15. I'm just going to come right past it, just like right here to represent 16. Then I have 24. Then I have 27. Then 35, so that one's going to go right over the 35. Then I have 36, which would go right here. I have 37. I'm getting a little close here. So let's do this. Let's go back and kind of fill in. So I've got 35, I've got 36, 37, and I've got 39. Okay? So then I have my very last number is my number 55, Miss Minnick, and that will go right here. So I know that each X equals one adult. So my number of X's should be the same as the number of Post-it notes that I have. So let's count them and just make sure. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 Post-it notes. So I should have that many X's. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have the same amount of sticky notes that I do as X's, which is right because we know one X represents one adult. So a line plot is very easy to read. Like I said, the X's represent the students. And so if I pointed to this X and said, how many linking cubes did this student draw with this X? All you have to do is just look down at the number and you would say, oh, this student drew 5 linking cubes. Same thing for this one right here, maybe. If I said, how many linking cubes did this student draw? You would just come down, this one right here, this student. You would just come down and you would see what number. It's a little bit past the 15, so you would say 16. So now that I've got all of my data in order from least to greatest, and I've got my line plot, I want to look at this number, which is Miss Gentry's 5, and I want to look at this number, which is Miss Minnick's 55, okay? In terms of the data, so remember all of the numbers, that's our data. In terms of the data, what is special about these two numbers? What do they represent when we pull them back? If I were to put them back here and here, what do they represent in this set of data? They represent the smallest number and the biggest number, right? So what we need to realize is that from the smallest number to the biggest number, all of the other numbers in our data are between these two numbers. So these two numbers represent the range. And the way that we find range is we do the biggest number minus the smallest number. So we could do 55 minus 5, and that would give us 50. And that is the range, R-A-N-G-E. The range of the data is the biggest number minus the smallest number, okay? Because every single number in our data falls between that 5 and that 55, and that gives us our range. Okay, so now that we found our range, do you think that it would be helpful for us to find the middle number in our set of data? So let's think about what does our middle number mean, okay? So we already said that finding the difference between the largest number and the smallest number is our range. So when we find the middle number, what we are looking at is the median. And the easiest way to remember that is when you're driving down the road and there's a patch of grass in the middle of the road. It is called the median. So let's look at how to find the median or the middle of our set of data. So all we have to do is we just have to find literally the number that is in the middle. So what I'm going to do is I'm going to start at the front, and I'm just going to kind of put a check right there, because I'm going to take one from the front and one from the back. Okay, and I'm just going to keep doing that back and forth until I find the number that's in the middle. So I'm going to go back to the front, 16 and 39, 24 and 37, 27 and 36, and the only number that I have left is this number right here, which is Coach's. I'm going to put kind of a star right there. So that 35, that number is our median. So our median, that is our number that is directly in the middle. So now that we found our range and our median, we are going to be looking for another number in our set of data. And that number is called the mode, okay? The mode of any set of number is the number that occurs most often. And the best way to remember mode is that mo and mo. Mode is the number that you see the most. Mo and mo. They both have that M-O. So remember, mode is the number that you see the most. So that means if there was a number in our set of data that was on here more than one time, that would be our mode. Now, I'm going to ask you, are there any numbers that you see on here that occur more than once? Do you see any numbers that are repeating, basically? Are any of these numbers repeating? No, none of the numbers are on here more than one time. 5, 16, 24, 27, 35, 36, 37, 39, and 55. I didn't say any of those numbers more than once. So what that means is for this set of data, our mode, I'm going to come down here, our mode is not 0, okay? Because what that means is that there is a 0 on here and you see it more than one time. So you would never write your mode is 0 unless it actually was 0. What we would write in this case is that there is no mode. Because there is no number in my set of data up here, there's no number that occurs more than once or most often. Okay, so we have found our range, our median, and our mode. So now let's talk about a concept that's called fair share. Fair share. Okay? Now, this concept, if you have a fair share of something, it means that everyone within maybe a classroom, everyone has a fair share or everyone has the same amount. So when we look at all of our data here, does everyone have a fair share? No, they don't. Everyone has a different number of linking cubes. So if I wanted everyone to have a fair share, all I would have to do is just take up everybody's numbers or take up everybody's cubes. So if this was everybody's cubes, if these were actually their cubes, I could take them all up and put them all in one bucket, add them all together, and then take them and give Miss Gentry some, Miss Minnick some, Miss Cooper some, Miss Littlejohn some. I could add them all together and divide them all up so that everyone gets a fair share. Now, to go with our data, what this is called, our fair share, is called our mean, okay? So it would go right down here, our mean. So we have to figure out what is our mean. So like I said, if we added all of our Post-it notes up, all of our linking cubes, if we added all of them together and divided them all up, that is how we find our fair share. So now I need to take everyone's linking cubes and add them all together. So if I were going to take everyone's linking cubes and put them all together so that I could give everyone a fair share, the first thing I would need to do is add them all together. So I'd do 5 plus 16 plus 24 plus 27 plus 35 plus 36 plus 37 plus 39 plus 55, and I get 274. So what that number represents, 274, is if I took everyone's linking cubes and I put them in one bucket all together so that I could divide them out and give everyone a fair share. All of theirs put together is 274 linking cubes. So now that I have 274 linking cubes total, to give everyone a fair share of the linking cubes, I need to divide them among all of the adults that I had. So I had 9 adults, so I need to do the 274 divided by 9. So now that I've done my 274 divided by 9, I divided by 9 because that's how many
how many adults I had, and I want to make sure everyone gets a fair share. When I divided, you can see here that I got 30.44444 repeating. Now we're going to round that to the nearest whole number. So if we round 30, we look to its neighbor, we look at the back door to the 4, that 4 is going to make it stay a 30. So my mean, my fair share, is going to be 30. Everyone, all of my adults, when I add all the linking cubes together and divide them by 9, everyone is going to get 30 linking cubes. So now everyone has the same amount and everyone has a fair share. So after I added all of my data together, I added it all together and I divided by how many numbers, how many students, or how many adults I had, I get my mean, which when I round to the nearest whole number is 30. So if I added all of my linking cubes together, if I put all of the ones that everyone drew out, their handful, if I put all of their handfuls into one bag and then divided them evenly, gave everyone a fair share, which equals my mean, they would all get 30 linking cubes. So everyone would have that fair share. Okay, so now that we have figured out how to find our mean, median, mode, and range, I want you to go grab your math notebook. I'm going to give you 1 minute to do that. So in your math notebook, I want you to take one clean sheet of paper and I want you to just divide it into 4 sections, just like this. And I want you to label them mean, median, mode, and range. Mean, median, mode, and range. That's a D. So it should look like this: mean, median, mode, and range. And this is supposed to be an E. Miss Young is struggling. There we go. Mean, median, mode, and range. Now let's talk about how we found all of these things, okay? So when we did the mean, we added all of our numbers, all numbers, and then we divided by the number of numbers, right? So in our data over there, we had 9 people draw out handfuls of linking cubes. So we added all those 9 people's numbers together and then we divided by the number of numbers, which was 9. So however many numbers there are, that's how many you divide by. So that is our mean. So our median is the number in the middle. That one is so easy to remember. Median is the number in the middle. They even sound kind of alike. Median, middle, median, middle. Literally the number in the middle. So then we have our mode, and our mode is the number that we see the most. So remember, mo and mo, mode and most, mode, most. Mode is the number that we see the most. That one is very easy to remember. So if you see a number more than once, that is the mode. And then the range is our largest number minus our smallest number. So in your set of data, you have your largest number, subtract it from your smallest number, and that is your range of data. So make sure you have all of this copied down into your math notebook. Okay, so now I want to see how things will change if Miss Young reaches in and grabs a handful of linking cubes. So I'm going to count these cubes and I'm going to write down the new number. So I have pulled out 26 linking cubes. So now what I want you to do is I'm going to put up all of the numbers back up on the screen And I want you to figure out the new mean, median, mode, and range for the entire set of data, including my number. So I'm going to put my number in the list with everybody else's numbers that we just had. And I want you to see if you can find the mean, median, mode, and range. Now I want you to use your notes, use those notes that we just took to figure out how to find the mean, median, mode, and range. And now remember, this is our first day doing this, so this is just practice. We want to see, can you do it based on what we went over today and based on your notes? So if you didn't take notes, you need to go back, watch the video again, and you need to take some notes, okay? So we're going to see how you did, and we're going to keep working on this for the rest of the week, and we will see you in the next video. Bye, guys. So remember, the first thing you always do for mean, median, mode, and range is you put your numbers in order from greatest to least. So I've already done that for you, including my new number of 26.